Tidal power. Introduction. The tidal power plant, also called as an tidal energy, is a form of an hydropower that converts the energy to the tides into the useful forms of the power, mainly electricity. This is the only form of energy whose source is the moon. The two types of a tidal plant facilities: tidal barrages, tidal current turbines, dynamic tidal power. Tidal barrage utilize potential energy. Tidal barrage are typically dams built across an estuary or a bay. Consists of a turbine, slides, glades, embankments, and the ship's rocks. Two types: single basin system and the double basin systems. So tidal energy generates works as the tide comes into and again when it goes out. The turbines are driven by the power of the sea in the both direction. Tide coming in and the tide going out. So the single basin systems, during the flood, tide basins is filled in the sluice gates and closed. The trapping water gates are kept closed until the tide has ebbed sufficiently, and thus the turbines start spinning and the generating electricity. Flood generation basins is filled through the turbine which generates at flood tide. Two-way generation sluice gates or turbines are closed until near the end of the flood tide, when water is allowed to flow through the turbines into the basin, creating electricity. At the point where the hydrostatic head is insufficient for the power generation, the sluice gates are opened and kept open until the high tide, when they are closed. Double basin systems, there are two basins but it operates similarly and ebb generations. Single basin systems, the only difference is proportions of the electricity is used to pump water into a second basin storage. Annapolis is tide generation facility, Bay of Fundy, Canada. The construction based in 1981 and 1984. The generating capacity of the 20 megawatt and the net output generating power per year. The tidal current turbines make use of an kinetic energy, moves water turbines. In similar way, the wind turbines, the wind power turbines, operates during the flood and the ebb tides, consisting of a rotor, gearbox, and the generator. These three parts are mounted on the support structure. These are the three main: gravity structure, pilled structure, and the floating structure. Gravity structure are the massive steel concrete structures attached to the base of the units to achieve stability by their own inertia. Pilled structures are pinned to the zipped by one or more steel or a concrete piles. The piles are fixed into the zipped by the hammering if the ground conditions are sufficiently soft, or by the pre-drilling position and the ground tip if the rocks is harder. Floating structure provides a potentially more convincing solution for the deep oceans. This is a support structure of a concept. Dynamic tidal plants. Dynamic tidal plants, or a DTP, is a new and the untested method of a tidal power generation. It would involve creating large dam-like structure extending from the coast straight to the ocean with a perpendicular barrier at the far end, the forming a shape of a T. A single dam accommodated with an over 8,000 voltage G voltage what is initially capable. A DTP dam is a long dam 30 to 60 km in which build is perpendicular to the coast, running straight in the oceans without enclosing an area. Other concern includes shipping routes, marine ecology, sediments, and the storm surges. The features of a helical turbine. Basic concept: designed for the hydroelectric applications in the free-flowing water, operates in ocean, tidal, and the river currents, does not require expensive dams that can harm the environment. Feature of the helical turbine: operating self-starting with the flow as low as 0.6 meter per second, smooth running, rotates in the same direction regardless of the direction of the flow, making it ideal for the tidal. Types of tidal steam generators. Since tidal steam generators are an immature technology, no standards technology has yet emerged as the clear winner, but a large variety of designs are being experimented with, some very close to large scale deployment. Major two types of tidal steam generators: axial turbines, vertical turbines, horizontal turbines. Axial turbines, these are the closed axial traditional wind farms operating under sea. Verticals and horizontal cross flow turbines, these turbines can be deployed either vertically or cross and concept of both power facilities. Tidal barrages. Mature technology has been around for the nearly 50 years. Reliable energy but high cost construction Environmental impacts of marine life, low power out. Tidal, able to utilize both ebb and the flood tides. The tidal converts turbines are not large, but tidal currents turbines technology is young in its development, installation and the maintenance changes. The environmental impacts are